In this particular lesson, we will learn about simplifying radicals, lesson 5.2. Uh, After this lesson, you will be able to simplify radicals using the perfect square method and or the prime factorization method. Now, what is a radical? A radical is a term using the square root symbol that represents taking root of a number. The radicand, in this case here, you see 7 here is the radicand, is the number under the radical sign. The index indicates which root is desired of the number under the radical. So in this case, the index is 3. Note that if you're taking the square root, even though the index is 2, we usually don't write that index. It's just implied right there. So again, index 3, radicand 7, and then this number in front of the radical is the coefficient of the radical. Now, what are perfect squares? If a radical is a perfect square, or maybe if a radicand is a perfect square, then it means that when you take the square root of the number, you get a whole number. For instance, all these radicands here are perfect squares. 4 is a perfect square, 9. When you take the square root, you get a whole number, right? When taking the square root, what is you should ask yourself? You should ask yourself, what number times itself, the index number of times. In the case of square root, the index is 2. So in the case here, 5 is that number when multiplied by itself gives you 25. 6 is that number when multiplied by itself gives you 36. So you're asking yourself the number of times itself, the index times will give you the radicand. So sometimes if a number is not a perfect square, you can just use your calculator and get an approximation, like in this case, right? Square root of 34 is 5.8. Or you can go over here and simplify that radical using taking it to the simplest form. For instance, in this case here, this root 18 in the simplified form is 3 root 2. We'll get into details how we arrive at this solution. Now, look at the product rule. This product rule is what we will be using in order to simplify radicals. You must understand this here. You must understand the product rule of radicals. So this is what the product rule is. If you have two radicals here, you can multiply them, a and b being the coefficient of these two terms. When you multiply them, you multiply a by b. So this a multiplied by this b, that's what you get here. And then you multiply this root x by root y, and you get this root xy. So this is what you need to understand in order to simplify any radical. Conversely, if you have this root 48, that is also equal to the square root of 16 times 3, because remember, this is equal to 16 multiplied by 3, because this here is the same as that, because 16 by 3 is 48. So this is the rule we need to have some understanding about. Now, like the objective said, these are the two methods we're going to be using to simplify radicals. Find the perfect square, and then use prime factorization method. Let's look at the perfect square method. Now, if I'm going to simplify this term here, or this radical, root 24, first I would have to find the factor pairs that when multiplied gives you that. If you look, these are all the factor pairs. 2 by 12 is 24. 1 by 24 is 24. 8 by 3 is 24. 6 by 4 is 24. So once you list all these factors uh, or factor pairs, you look through them and see which one have the largest perfect square, right? In this case here, the largest perfect square is 4, right? So we would use this pair here, this 6 and 4, 6 and 4. That's your pair, 6 and 4. So we're going to use that. So we're going to split this 24 up into root 6 times root 4 times root 6. And this is what we are going to be using, because when we take the square root of 4, we get 2. And then it becomes 2 root 6, because you can't simplify root 6 any simpler. So this 2 root 6 is the simplified version of root 24. Now, this is the way you do prime factorization, and this is what you would use to simplify radicals using the prime factorization method. So this is what is called a factor tree, right? I'm breaking this 48 down into these prime numbers. So this multiple of primes here, if you notice that all these prime numbers when multiplied by each other gives you back the 48, right? So you're just splitting this number down into all prime numbers. Now let's look at how we can use that method to simplify a radical. So we're trying to simplify this radical here, this one root 80. So we're gonna do the prime factorization here, right? So prime factorization there is like if you go over here and you have this 80 here, I can split this here into 8 and 10. Then I can split this 8 into 2 and 4, and then that 4 into 2 and 2. So I got this guy, that guy, that guy, and this guy will be split into 2 and 5, right? So all these are prime numbers here, right? But the thing is once you split them down like this, you circle pairs. If I circle this 2 here, I'm circling this guy here, these 2 here, and then I circle these 2 here. So this here will actually work out to 2 and 2, because this is actually what is happening. Like if I go, we're actually saying that square root of 80 is equal to the square root of all these numbers here, 2 by 2 by 2 by 2, right, by 5, right? But on 2 by 2 could be, 2 by 2 is root 2. So I can actually say this is equal to the square root of 2 squared. You see, if I put these two together, this is exactly what we're doing here, times 2 squared. I'm putting these two together, and then I have 5 left. But if I take the square root of 2 squared times the square root of 2 squared times the square root of 5, I'm going to come back to this same answer here, because the square root of 2 squared is 2 times the square root of 2 squared is 2 times square root of 5. So 2 by 2 is 4 root 5. And that is really the gist of what is really happening here when I simplify using the prime factorization method. So there you have it, two different ways of simplifying radicals, prime factorization method, and of course the perfect square method.